we are discussing about the location of roots. Three cases I have discussed. Now there is a fourth case, case 4. What is the case 4? That if one of the roots lie between the two numbers, then find the condition. If one of the roots of ax square plus bx plus c is equal to 0, ABC belongs to real number, lies between two numbers K1 and K2. K1 is less than K2. K1, K2 are real numbers. Then find conditions. So what are the conditions? What can be the condition? In the question, it is saying that one of the root lies between the two numbers. Then what will be the cases? Let's say here K1 and K2. This is K1 and K2. This is x-axis. This is x equal to K2 and this is x equal to K1. So what can be the possible cases in this case? One of the root may be like this one. If the graph passes like this one, if we draw the graph of a times fx versus x, then this can be the case. This can be alpha, this can be beta, or there may be another case, K1, K2 this type, and root may be like this one. Graph passes like this one. Alpha can be here and beta can be here. So in this case, alpha lies between K1 and K2. In this case, beta lies between K1 and K2. In both cases, both are satisfying that one of the root lies between the two numbers. So what can be the conditions? See here, we know that between two numbers, any number exists in between the two numbers, then the two numbers must be different. That means, first of all, D must be greater than 0, because in this case one of the root lies between these two, then other root must be outside. In this case also. So first of all, one condition is what? D must be greater than 0. And second case is what? If you see here, at x equal to K1, a times f of K1 is less than 0 here, and in this case, a times f of K2 is positive. Here also, a times f of K1 is positive, and in this case, a times f of K2 is negative. Both cases we can study separately, but no need to study separately. We can combine these two cases in one form. If you see the product of a times fk1 and a times fk2, if we see the product of these two values, a times f of k1 into a times f of k2, if you see the product of these two values, this is negative, this is positive. If you multiply, then multiplication of positive and negative number will be what? Negative. So in this case is negative. In this also, this is the positive value and this is negative value. If you multiply these two values, then there will be negative value. So this is the condition satisfying both the cases. That means if you simplify this, this will be a square fk1, fk2 will be what? Less than 0. So first condition is this one and second condition is this one. Now let's take example. Take example. If one of the root of the equation x square plus k minus 4 into x plus 2k minus 3 is equal to 0 lies in the interval minus 1 to 1. One of the root lies between minus 1 to 1. Then what will be the interval of k? Then find interval of k. So this is the question. Now what will be the solution? Solution will be, in this case we study there was two conditions. First condition was d greater than 0 and second condition was a square into fk1 into fk2 will be less than 0. So we have to apply the two conditions. D must be greater than 0 and second condition was a square fk1 fk2 must be less than 0, right? So first of all recognize which one is k1, which one is k2, what are the values of ABC. So if you compare this value with ax square plus bx plus c is equal to 0, then a is equal to what? 1, b is equal to k minus 4 and c is equal to 2k minus 3 and k1 is what? Minus 1, k2 is what? 1. So these are the values. This is k1, this is k2 and coefficient of x square is here 1, so a is equal to 1. Now coefficient of x is what? K minus 4, so b is equal to k minus 4 and constant term is what here? 2k minus 3, so c is equal to 2k minus 3. Now find out the discriminant first. This is what? B square minus 4ac will be greater than 0. So this will be what? K minus 4 whole square minus 4 into 1 into 2k minus 3. This must be greater than 0. Now simplify this one. So this will be k square plus 16 minus 8k plus 12 greater than 0. So this is k square minus 16k plus 28, it will be greater than 0. Now factorize this one. So this will be what? K minus 14 into k minus 2 greater than 0. So answer will be what from here? Minus infinity to 2 union 14 to infinity. So this is the answer for case 1, condition 1. Now solve the condition 2. A is what? If you compare, a is equal to 1. So this is 1 square into fk1. Find out first f of k1 is what? That means first of all fx is what? Fx is x square plus k minus 4 into x plus 2k minus 3. This is our fx. Now find out f of k1. f of k1 means what? F of k1 is minus 1. That means f of minus 1. Put here in place of x minus 1. So it will be how much? It will be minus 1 square plus k minus 4 into minus 1 plus 2k minus 3. So this is what? 1 minus k plus 4 plus 2k minus 3. That means it will be k plus 2. Now find out f of k2. F of k2 will be what? K2 is what? 1. That means f of 1. So find out, put x equal to 1 here both sides. So it will be 1 x equal to 1. So it will be 1 square plus k minus 4 into 1 plus 2k minus 3. So this will be how much? This will be 1 plus 3k minus 7. That means 3k minus 6. Now we have to apply this condition. That means a square fk1 into a square fk1 into fk2 will be less than 0. Now put the values. So this is 1 square into fk1 is what? K plus 2 and fk2 is what? 3k minus 6. This will be less than 0. Right? So what will be answer from here? This will be what? Answer will be from here 2 minus 2 to 2. So this is the answer from case second. Now after solving all these cases, we have to find the intersection. That will be our answer. So now find out the intersection between these two cases answers. So first of all is what? This is the first answer. So this is 2 and this is 14. So this is what? This is minus infinity to 2 and 14 to infinity. So this is first answer, this is first answer. Now second answer is what? Minus 2 to 2. Minus 2 will be here and 2 is this one. So minus 2 to 2 is this one. Now take intersection. So if you take intersection, there is no intersection here, there is no intersection this side. So only intersection is what? This one. So answer will be what? Answer will be k lies between minus 2 to 2. So this is our answer. This is the final answer. Now next case is, what will be the next case? What are the next condition? Case number 5. Case number 5. What can be the case number 5? If both roots of any quadratic equation lies between two numbers k1 and k2. What will be the case? If both roots of ax square plus bx plus c is equal to 0, abc belongs to real number, a does not equal to 0. This is quadratic equation. So in every case, a is non-zero number. If both roots of this quadratic equation lies in the interval k1 to k2, k1 k2 are real numbers, then what will be the condition? Find the conditions. So what will be the conditions? What can be the conditions? See here, if you mark the numbers k1 and k2, then what can be the possible cases? It is saying first of all, both roots lie between k1 and k2. That means the quadratic equation must have real roots. So what can be the possible cases? Both roots lie between these two numbers. So roots may be distinct type, then both roots can be between K1 and K2. Or what can be other case? If K1 is this one and K2 is this one, then root can be equal. This case is also possible if we draw A times fx graph versus x, A times fx graph versus x, right? So first of all, there can be these two cases satisfying the conditions. So one condition you have to apply, b greater than or equal to 0. Second condition is what? See here, at K1 and K2, at K1 graph is representing positive value. In this case also, in this case also. That means A times fk1 is positive. Third is what? A times fk2 is positive. And fourth is what? Fourth is what? K1, K2, K1 is what? Is smaller than K2. We know in between, we know that in between, this is the point where x is equal to what? Minus b by twice. So we have to restrict that K1 should be this side and K2 this side, because K1 is less than K2. Then only the two real roots lie between K1 and K2. That means K1 must be less than minus b by twice a, and minus b by twice a must be less than K2. So fourth condition is what? K1 is less than minus b by twice a and less than K2. If we apply second and third condition, that means A f K1 positive, A f K2 positive, then in this case there is no restriction that K1 is less than K2. K1 may be this side or K2 may be this side. In both cases, A f K1, F K2 will be positive, but we want K1 this side and K2 this side, because here it is given roots must lie between K1 and K2. K1 is smaller than K2, so K1 should be this side and K2 should be this side. So these are the four cases. Now solve and take intersection between all these cases. You will get your answer. So these are the four conditions. Solve and take intersection between all these cases. Now there is another condition. There is another condition. What can be the next case? What can be the next case? If both roots of, what can be the next case? Next case can be that if one root of ax square plus bx plus c is equal to 0, a, b, c belongs to real number, a does not equal to 0. If one root of this is less than k1 and other root is greater than k2, then find the conditions. What can be the cases in this case? So what can be the conditions? See here, in this case it is saying that K1 is from the question, it is saying that one root is less than k1 and other root is greater than k2. K1 is less than k2. It is given. Let's say. So what can be the possible cases here? One root is less than k1 and other root is greater than k2. That means if we draw the graph between the a times fx versus x, then graph will be like this one, because here this is alpha and this is beta. Alpha is less than k1 and beta is what? Greater than k2. This can be the possible case. Then what will be the conditions? From the graph, d must be greater than 0 because there are two distinct roots. k1 and k2 are distinct numbers. So these alpha beta must be distinct roots. So first condition is what? First condition, d greater than 0. And what can be the second case? Second case is what? If we find the value of a times fk1, value of a times fk1 is what? Less than 0, and value of a fk2 is what? Less than 0. So this is the second condition. A times fk1 is less than 0, and third case, a times fk2 is less than 0. So these are the third conditions. These three cases, solve these three cases and find out and take intersection. That will be your answers. So these are the three conditions. Solve and take intersection. Take intersection between these three cases. So you will get your answers. Now we will do questions on these three cases in next class.